Welcome to the webinar. Today, I'm going to talk to you about Docker. Right? So we are going to have a 1 hour discussion. I'm going to explain Docker as much as possible that can be done in 60 minutes. Right? So it's going to be an introductory session. Yeah, you guys will be able to understand at the end of the session what is Docker, why do we use it, and how you can use it in your DevOps applications, right? So to deploy applications or to create development environment um, or reproducible development environment on your local machines as well. Okay, so we are going to learn about Docker today. All right. So for my explanation, I'm going to use this paint window, right, to draw some diagrams and to talk about things. And we are also going to have a little bit of demonstration. Okay, and the last 15 minutes or 10 minutes we are going to reserve for Q&A, and that's when you can ask me your questions. All right, so if you have any questions, please do not send me now on the chat window. We are going to utilize the last 15 minutes to answer any queries. All right, so before we begin the session, let me briefly introduce myself. So let me also zoom in a bit on this text. Yeah, so my name is Amit Kumar. Yeah, and I have an experience of 17 years, and almost most of it, around 15 years, is in DevOps. Right, I'm based out of Bangalore in India, and right now I work as a principal architect in a product-based MNC. All right, so this is me, and I'm going to talk about Docker today. Okay, so let's see, what is Docker? Now, to understand the usability of Docker, let's first understand a problem. Right? What problem Docker tries to solve? Let's say you have a web application. You have a web application, and let's maybe call it as, let's say, my app. Right? Let's just say web app. Okay, and this web application could be written in JavaScript, could be written in Java, could be written in C#, Python, whatever. That does not matter as of now. So this is a web application, and you want to host it. You want to host it so that external users can use this application. Okay, so the end goal is that you have some users, right? Maybe these are the users who are sitting somewhere in the world, and they all should be able to access your application, right? You want them to access the application. And the problem is, how do you host it, right? So traditionally, how do you host an application? What we do is we identify a server, right? So we identify a server, or also known as host, right? And on the server, you have some hardware, right? CPU, RAM, and all that stuff. And on top of that, you deploy the application, right? Now, let's assume that this application is Java-based application, right? So this application is written in Java. Let's assume that, right? It's a Java-based application. Now, to run this application, you need to set up the environment. Is my audio clear for everyone? All right, good, thanks. So we need to ensure that the environment for deploying this application is available on this server. So how do you make the environment available? You install that environment. So maybe you need to have Java runtime installed, right? And then you need to have maybe a web container installed, or a Java servlet installed, right? So maybe you want to have a Java runtime installed here, Java runtime, and you want to have a servlet, Java servlet application like Tomcat, right? And on top of this application, you can host your Java-based web application. Okay, so this is a typical architecture on how a Java application is deployed. Okay, so this is the replication. The red one is the replication. The brown one is the physical server, and the blue ones are dependencies, right? So the red one is your application, right? This is your application, and the blue ones are dependencies. So it is dependent on certain binaries and libraries to be available. So your web application will not work properly unless it has some binaries and libraries available to it. And in this case, it is this Java and the Tomcat, right? So you manage these dependencies on a server, then you deploy your application, and it works fine, right? It works fine. Maybe it works on port 8080, right? Generally, so on port, let me choose a different color here. Yeah, so maybe the application is available on certain port 8080. This is where your application is available to end users, right? Traditional deployment. Now, if this web application is a product, right? Maybe it's a web application which many other organizations or many other teams want to deploy in their environment. Let's say you are the vendor of this web application and you sell this web application for other people, and they can run this web application on their system. For example, Jenkins. Jenkins is a web app, right? You can run Jenkins on your systems. So if Jenkins wants to sell their web application, they have to give the Jenkins binary to you guys, and then give instructions on how you can set up the dependencies, set up the server, all the libraries and binaries, how you can get them up to install Jenkins itself, right? So if this application is Jenkins, then this is coming from the vendor, and that dependencies and libraries and binaries are to be resolved by the user or by the team who is going to deploy this, right? So if a customer wants to use your application, they have to set up this whole environment so that this application works fine, right? What is the environment? Everything which is highlighted yellow is the environment that needs to be set up by the customer. So the yellow things, including the libraries and the server itself, are to be set up by the user, by the customer, and the application is provided by the vendor. Now, many times, the vendor who is developing this application, the web application, may get queries from the end users that the application is not working on their system, right? So if a customer is trying to deploy the application on their infrastructure, the vendor may get queries like, the application is not working on my system, I'm following your instructions. Or they may get a query that I'm not allowed to install Java. We have an older version of Java, we cannot run a new version of Java. Or we don't have Tomcat on our infrastructure. So if the customers are incapable of setting the environment properly for running your application, well, that's kind of a deal breaker. How do you solve that problem? How the vendor enables the customers to deploy the application that is given by you without worrying about the environment, underlying environment, especially the dependencies, right? So what do? traditionally, just give me a second. Yeah. So traditionally, what happens is the vendor, the vendor is going to create a web app, right? The application, and the customers the customer is going to, on their servers or on their hosts, is going to download this application and set up the environment so that the application can run here, right? Setting up this environment is their responsibility. But now, using Docker and many other containerization technologies, what vendors can do is, apart from delivering the application, they can also deliver, along with the application, some binaries and libraries. So all the dependent binaries and libraries for your application can be bundled together in something called as an image, or container image. And then the customer can download the complete container image on their system, the container image. So maybe I'll just erase some of the stuff. So the customer can, on their server, customer can download this entire image from the vendor, and then this image contains everything, right? This image contains the application, the dependencies, right, which is the libraries and binaries. It's plus binary. Right, so this image, which is developed by vendor, is downloaded by the customer, and then this entire bundle, which contains the application, the dependencies, this entire bundle can be executed as a container. Right, so this container is nothing but a small, tiny, kind of a virtual machine which runs within this bigger customer machine. And this container contains everything, including the application and the dependencies. That means the libraries and binaries required to run the application, right? So this container contains everything, the running application and the dependencies for the application. And the end users can access the application on certain port here. So maybe on a port of container, right? Maybe port 8080 of the container. The users can access this application, right? So this solution, which is known as containerization, just give me a sec. So this solution, called as containerization, allows developers to bundle application along with the environment into an image, and that can be consumed by the customers who want to deploy the application. So they will download this entire bundle which contains everything, and execute that bundle itself. Make sense? Yeah. So how does it work? So Docker is a solution for this. Docker enables the concept of containerization. So let me show you how it works. So I'm going to just look for Docker architecture diagram. Let's see. Yeah, this one will work. Yeah, so this is how Docker works. Okay, so when you have a machine where you want to do all this, right? So these are the components that are involved. If you want to use containerization, these are the components that are involved. Okay, so I'm going to copy this image and put it on Paint. Yeah, here. Okay, so what happens is you find a machine called as Docker host. Okay, so this is nothing but a server or a VM or whatever, or a laptop. And this is a machine which has Docker installed on it. Okay, machine has a Docker installed on it. So you can see here, it has Docker daemon run. So a machine where Docker is installed is called as Docker host. This is a Docker host, a machine where Docker is installed. Then developers can create images. So you can see locally images can be created. Or if somebody wants to use image created by other people, maybe a vendor image or a partner image or image created by your teammates, they can also download images from externally. So for example, this image is being downloaded on this Docker host. See here, this line. Yeah. So this image is being downloaded from here. So there is a service called as registry. A registry is a service which allows people to publish their Docker images. For example, GitHub allows people to publish their Git repositories. YouTube allows people to publish their videos. Similarly, Docker registries allow people to publish their images. So a person, someone sitting somewhere may have another Docker host, right? On a Docker host, they can create an image. So they can create an image, and those users can publish the image onto the registry. And other people on other systems can download that image from the registry. Yeah, this is how the images are transferred from one place to another place. Make sense? Okay, so now we are going to demonstrate on how do we use the images, how do we use the containers, how do we create containers, and how do we consume the images created by containers. Okay. All right. So let's first take an example Give me a second. This Zoom toolbar is kind of interrupting. Yeah. Let's say we go to a place called hub.docker.com. This is a place. This is an example of a registry. Docker Hub is a registry. Okay. And if I click on this explore button, you can see many Docker images developed by many vendors and made available here. Right? For example, Nginx. Nginx is a Docker image which is made available by Docker themselves. So that's why it says it is a Docker official image. It is made available by Docker themselves. And you have the documentation here, right? So Nginx is a reverse proxy and a web server for HTTP, and it allows you to deploy a web application. So it's a web server application, right? And there is a Docker image which has the complete application and all the dependencies, all the binaries required to run that application. So what I'm going to do is to demonstrate here, I'm going to show you how you can run an application which comes as a Docker image, and how you can run it or host it on your own system, how you can set up a Docker host, and how you can run an application, a Docker image-based application on your system. Okay, so for the demonstration, we have an EC2 machine here. We have an EC2 instance. So I'm connected to the instance here, and I'm going to become root. Right? So to run Docker commands, I need to be root. So that's why I have become root here. Now, on this machine, this is a brand new machine. I just created it 2 minutes before I started the session. So if I want to see if Docker is installed, I can just run a command called Docker, and it says Docker is not found. Right? So how we can install Docker? Well, I can just say apt install Docker, docker.io. With this command, I should be able to install Docker on an Ubuntu-based machine. But what if you're not using Ubuntu machine? You are using Red Hat, or you're using Alpine Linux, or Windows, or Mac. How you are going to set up Docker? So you can just look for Docker installation documentation. So if you say Docker installed, the first link is install Docker engine. So here you can see if you want to install Docker for Linux, or Docker for Windows, or Docker for Mac. Yeah. Generally, you should not try to install Docker desktop. What you should do is you should try to install Docker server. Okay. If you're on Windows, then you have to install Docker desktop, because for Windows, you don't have Docker server. So let's say Docker server you want to install on Ubuntu. Let's go here, and you can find here installation methods. Right? So on some operating systems or some instances of operating system, you may have to set up the repository, apt repository, to install Docker. So there are exact steps. You can run these two commands first, then these two commands next, then this command, and then finally you can install Docker. Okay, on AWS Ubuntu machines, I can just say apt install docker.io. But before this, because it's a new machine, I'll do an apt update. It's going to update the cache. Yeah, and I can say apt install docker.io. And I got a confirmation from yes. clear the screen. And if I run a command called Docker, I get some output. So that means Docker is now working fine. Okay, you get some outputs. So that means Docker is installed on my machine. This machine is now a Docker host. Right? So I can run containers on it. How do I run a container? How do I run an application which came as Docker machine? So let's say I want to run the application which is bundled in this particular Docker image, Nginx based Docker image. So I can just first download this image. Okay, so the command that I need to run is docker pull nginx. So let's copy this command. And on the machine, I'm just going to paste this command, docker pull nginx. This command is going to download the nginx image from Docker Hub. Done. Docker image ls is the command which is going to show me all the images that are available locally. So if you see here, it tells me that Nginx image is available on my local system. Right? So this image is called Nginx. It is of the version latest. The ID of this image is this. So the ID of an image is unique. Right? So each image has a unique ID. This is the ID for that. Okay, so it is downloaded now. Now, how can I run this application? Very simple. I can just say docker run and the image name, docker run nginx. And when you run this command, please note I did not install nginx. Right? I did not install nginx at all. I just installed Docker once. I pulled the nginx image. It contains everything required to run nginx. And I said docker run nginx. When I press enter, it's going to run the nginx application. Okay. Now, unfortunately, when you run a container like that, it runs the container, but it runs it with attached to the standard input and standard output. So your terminal is lost. So what we do is we generally run the containers in background. Now, how do we do that in background? I press Control C. That means I stop this running container and I say docker run nginx, but I run it in daemon mode or detached mode. So I say -d, run the application in detached mode. Press enter, you get some random string, which is the ID of the container that is just created. And now my container is running. Okay, if I say docker container ls, then it can show me which container is running. You can see here one container is running. This container is based on image nginx. This is the ID of the container, and this is the name of the container. And the container is running an application on port 80. Okay. Now, how do I access the application running in this container? So as I showed in this diagram, you download the container image onto your local machine, and then you run a container, right? So you download the container using docker pull command, right? And then you run the container based on the image using docker run command, right? These two commands we have just seen, right? So Docker run is going to run the container, and we see the container here. And now we can access this application by connecting to the port on which the application is running on the container. So if we know the IP address of the container, we can talk to the container on the port 80 here. We already know port 80. So let's inspect this container. Docker container inspect, and we can inspect a container, which means we can extract almost all the details about a container, every detail we want to see. So when I run this command, a lot of detail is shown. But I'm interested in the IP address of the container. So the IP address of the container is 172.17.02. Right? If I say curl, one 0.2 and press enter, I get Nginx. Right? So I can access on port 80 on this IP address my Nginx application. And that's it. You can just run any application like that without installing, without configuring anything. Everything will be running out of the box. Right? Let's say you want to run Jenkins on your system. So how do you run Jenkins on a system? Generally, you have to install it. So if I go to Jenkins Ubuntu installation, if I go to Jenkins Ubuntu installation, go here on Ubuntu. You have to ensure that you can install Jenkins by running these 4 commands. Pretty simple, but there are these prerequisites. You should have Java installed, right? For Linux, you have some other configurations required, right? So you need to do all these things, or you can run it using Docker. You don't need much of a requirement except the hardware resources, right? So you can just say Docker run, and that is enough. You don't even need to give all these parameters, right? So there is an image called, let's see, the image name is not specified here. Yeah, maybe this is not a very good documentation. So what we can do is on the Docker Hub, we can look for Jenkins. And you can see here there's an official Docker image, but it is deprecated. We should use Jenkins/Jenkins image, which is here. So I can download this image and run container based on this. So I copy it, and on my machine here, I can say Docker pull. Oh, come on, see, I copied the entire command, but I retyped it. So I'm pulling the Jenkins/Jenkins image. Now this image contains Jenkins and everything required to run Jenkins. Done. Now if I say Docker image ls, you see here Jenkins/Jenkins is an image downloaded. It is around 463 MB in size, and I'm pretty sure that this 463 MB contains the Java that is required to run Jenkins, the Jenkins binary itself, and all other configurations. Now I can run a container out of it. I can say Docker run -d Jenkins/Jenkins. And I can also give this container a name. I can say my Jenkins. So it should be -name. So it runs a container. If I say Docker container ls, you can see there is a new container running here with this particular ID based on Jenkins, and this has got the name my Jenkins. The previous container got a name automatically because we did not specify any name. But this time we have got a name called my Jenkins, and it is running on port 8080. Now, if I inspect this, Docker container inspect my Jenkins, and I can see the IP address, which is 172.17.03. If I say curl 172.17.0.3, port 8080, right? This is port 8080, not 80. And you get connected to Jenkins. But here you get an error. It says authentication is required. So you get error 403 here. So maybe it's a good idea to access this application via a browser so that it can redirect you to /login page. Okay, so let's do that. Now, the problem is in this instance, I don't have any GUI, so I cannot open the browser. But one problem that you would have seen now is we are accessing the application using the IP addresses of the container. That means we are accessing the application within the Docker host itself. These IP addresses are only valid within the Docker host. These IP addresses are not valid and not reachable, not accessible from any other machine, right? Because you can see here from the image which I am painting here, this container and the IP address is local to this particular server, right? Now, if we want people outside of this machine to access the application, what we need to do is we need to publish the ports, right? So for example, we need to do something called as port forwarding. So we can say that there is a container running on port 8080, and since it is a local container with local IP address, I want to publish it to external people. So I want to create a port forward, right? Maybe for example, this port forward could be for port let's say 7777. So any user, can access my application by browsing to this server's IP address on port 7777. Any communication coming here will be redirected to this port on this container, and the request will be served back. Okay, so how do I do that? It's pretty straightforward. First of all, I'll stop this running container. The Docker container ls shows me the containers. I'll say Docker rm, which is remove, or I'll say container remove my Jenkins. So I want to remove forcefully my Jenkins container. So once it is done, I'm going to run the container again, but this time I'm going to give a command called -P. Capital P command is going to publish our image or publish our container or publish our ports actually to external world. So let's run this command. Container starts, Docker container ls, and it shows me that this Jenkins container is now running. And here now you see some more information for the ports. This means that now the port 49154 on this host is actually going to listen to incoming requests, and any request that comes on this port will be redirected to port 8080 on this container. Yeah? So if I find out the public IP address of this instance, which is this one, and if I go to this public IP address and go to port 49154, Hmm? Okay, maybe there is a problem here. Just give me 1 second. Should work. $54, $89, $24, $88. And it is 49154. Should work. Let's try something else. So maybe it's working for you guys. Maybe it's this port is blocked on my laptop. Can you guys try? If you can access this URL, I'll just message it to everyone. You guys should see Jenkins. Yeah. So many people already see Jenkins here. Access is denied. That's fine. You cannot log into it, but that's fine. You can see Jenkins. Right. So this is how you can make it public. Maybe you can also see on port 49155. If you browse on port 49155, you can also see some application here. I can also maybe run the application, but this time I can also specify on which port I want to expose it or I want to publish it. I can say -p and I want to publish it on port 80, like that. So I can publish it on port 8080 also. If I say Docker container ls, you see now this application, which is Nginx based, will be available on port 80. So here, if I browse this IP address simply, I should see Nginx. Now port 80 is not blocked on my laptop, so I can browse Nginx here. Yeah. So this is how you can just run applications without worrying about underlying configuration. So I'm just downloading images and running them. Just Docker run command, and it's working fine for me. Okay. So this is the premise of Docker. You can create an image which contains your complete environment, and then you can run it anywhere. You publish once, you build the image once, and it can run anywhere. Okay, so that's all I wanted to discuss with you today. I can take some questions now, and then we can wrap it up. Okay, there are two questions. One is, what is Nginx? Give some info. Nginx is a web application, a web server which you can use to host your HTTP applications or create a reverse proxy. You can read about it later as well. Why do we need root to install Docker? So Docker runs with high privileges because it has to create processes which interact directly with the kernel. So that's why it requires administrative privileges. Okay. Any questions? Can I know how Dockerfile is used? So maybe we can do one more webinar where I can explain how you can build Docker images. So we have seen how do we consume Docker images, but how do we build them? How do we create them? That creation can be done using Dockerfile. So you can write Dockerfile. Well, Docker file contains all the instructions required to build an image. So we can have one more webinar about that. All right. Can you please use the steps of building your very own container image? Also the minimum requirements to run Docker. All the minimum requirements and everything is here in the installation page. You should be able to see requirements, right? So this is covered here by Docker itself. Also steps of building your own container image. Yeah, that requires a little bit more time, maybe around 30-35 minutes. So we need to do one more webinar. Can this be done on local machine also? Of course, on local machine, on your laptops, you can install Docker Desktop and run containers. Why are we using Docker Engine? We can use Docker Desktop as well. What is the exact difference between Docker and Docker Desktop? So Docker Desktop, let me take you to Docker Desktop. So Docker Desktop actually allows you to run in non-supported environments, right? For example, on Windows, you cannot run Linux applications directly. You cannot run containers. But using Docker Desktop for Windows, Docker can create a Linux environment using WSL for running containers, right? Containers is actually a Linux native concept. Windows is also coming into it, but till now we don't have first class support for Windows. So it uses WSL for running containers. So that's what Docker Desktop does. Don't worry about Linux Jenkins asking username password. Yeah, that's fine. You don't have credentials for login to Jenkins, and that's not the purpose of this session. So yeah, please ignore that. What are memory constraints of containers? Memory constraints of containers are, or you can say resource constraints, are defined by how much resources you have on the supporting server, the underlying server. Okay. Can we get recording? I think yes. SkillUpRight team is going to share the recording. I want to do changes in Nginx configuration. How can I do it in container? Very good question. So you can go through the Nginx images documentation, and here you have, I think, one section for configuration. See, you can mount your own configurations into the container. So read more about it. Difference between image and container. So image is a static file which contains everything required to run an application, right? So image is something which can be shared, which is not running. Think of it as a CD or as an ISO file. ISO file is what? It contains data to create a virtual machine, right? But when you run a virtual machine out of ISO, that becomes a VM. Similarly, image is static data which contains everything application and everything required to run your application, and the container is the running instance of an application. Will Docker is recommended in embedded? Not that much, but you can use Docker for very specific use cases like building development environments and things like that. Do you also need a script file to deploy the container image? Can you please take us through? You don't need any script file to deploy container image. We have seen a Docker run is sufficient. Can we have multiple ports on a container? Yes, you can, but you can have only one application run. So if that application serves on multiple ports, then you can have. How to integrate with Kubernetes? That's a separate discussion. Kubernetes is very complex discussion. So maybe sometime in future when we have webinar on Kubernetes, we'll take a look at that. Okay. Is it possible to modify port and IP in the container? Not the IP, but port, yes, it is possible to modify. What are other container solutions like Docker? You have Rocket Ship, you have Containerd, you have CRIO. There are many solutions. Is this compatible with all Linux flavors? Yes. So it is compatible with all Linux flavors. We usually get Docker removal in progress error. I'm not sure what it is. If you can share some error in details, we can talk about it. Okay. Can you give real time examples how companies are using that? Are using Docker? Almost all the organizations are using Docker to deploy applications. They're building the applications using Docker images and they deploy them on Kubernetes. So yeah. Difference between Kubernetes and Docker. Kubernetes is an environment which provides high available clusters to deploy Docker application. And this is a very short answer. If you want to have detailed answer, then you will have to wait for the next webinar. You are executing Docker commands in AWS. Can you tell us why or basics of it? No, I'm running Docker commands on an Ubuntu machine. This Ubuntu machine is hosted on AWS, but that is not relevant here. It could very well be a local or a web or a local VM or a local laptop also. So this server being on AWS is not relevant. Okay. Can I give one desktop application as Docker image? Unfortunately, no. It does not work for desktop applications. Okay. So then we can wrap up this session. Thank you guys for your time. And thank you for asking so many questions. I see that it's a very, very curious bunch of participants. It's really excellent. And hopefully we can meet again very soon sometime with another webinar. Right? Thank you. And I'll see you guys again. Bye.